Hi everyone, today I'll be talking about short and long reflexes of the enteric nervous system, which is often called the second brain of the body. Stick around to the end to find out why. This system is what lets our digestive tract coordinate movement, secretion, and absorption without us even thinking about it. So, without further ado, let's begin. The enteric nervous system, or ENS, is a system of neurons built directly into the walls of the gastrointestinal tract. It stretches from the esophagus to the rectum, forming a vast number of sensory neurons, interneurons, and motor neurons that control every step of digestion. What makes the ENS especially fascinating is that it has about the same number of neurons as the spinal cord. That gives us just a sense of how powerful it is and tells us that it's not just a simple reflex system. It's capable of processing sensory information, making decisions, and coordinating complex responses independently from the brain. The primary role of the ENS is to regulate digestion, and it does this by controlling a handful of key functions. First, it regulates smooth muscle contraction, coordinating our bodies to push food forward. It also provides secretion of digestive enzymes and mucus, ensuring that the food is chemically broken down and that the GI lining is staying lubricated and protected. Not only that, it allows for the regulation of increased local blood flow, which increases blood supply to active digestive areas so nutrients can be absorbed efficiently. And of course, it helps with overall gut motility, controlling the contractions and timing of the movement through each GI segment. What makes the ENS unique is that it works constantly, even if the brain is not giving active commands. For example, even if the vagus nerve, which is a major nerve from the brain to the gut, is cut, the basic digestive reflexes in the gut will still function. This shows just how independent and organized the ENS is. When it comes to reflexes that control digestion, we usually focus on two main types: short reflexes and long reflexes. Each one has a different role, and together they help digestion run smoothly and efficiently. So, now let's break down each type of reflex and see how they work in the digestive process. Starting with short reflexes. Short reflexes are built in automatic reflexes of the digestive system. What makes them unique is that they are handled entirely within the enteric nervous system, meaning the gut senses something and responds without sending signals to the brain or spinal cord, so it's completely independent of the central nervous system. This makes them fast, efficient, and perfect for managing moment to moment digestive activity. Short reflexes are controlled by the network of neurons located directly in the walls of the GI tract. Both the stimulus and the response happen locally, right in the gut, so there's absolutely no involvement from the central nervous system. A short reflex typically begins with a stimulus inside the digestive tract. These are stimuli that are detected by the enteric nervous sensory neurons within the GI wall. Once activated, these sensory neurons send signals to local interneurons, which process the information there. Then, enteric motor neurons immediately activate an appropriate response. Because short reflexes stay entirely inside the enteric nervous system, they allow the gut to react very, very quickly to what is happening inside of it, kind of like a self regulating smart system. The key takeaway here is that local reflexes will give local responses inside the GI tract with no brain involvement. A great example of this is when the intestines sense food in the system. So, as soon as food arrives, the stretch receptors in the intestinal wall detect the presence of incoming material. This signal doesn't have to travel anywhere fancy, it just stays right there in the gut. And the enteric nervous system immediately kicks into action and responds on the spot. One of the first responses is an increase in peristalsis, which is the rhythmic contraction and relaxation of the intestinal muscles. This is like a wave like motion that helps move food through the digestive tract, making sure that it progresses at the right pace for proper digestion and absorption. At the same time, the ENS triggers digestive secretions, releasing fluids, mucus, and digestive enzymes. These secretions will help break down food chemically, lubricate the intestinal lining, and create the ideal environment for nutrient absorption. What's important with this is that the entire process happens completely within the intestine. The brain doesn't have to get involved at all, which is why this is considered a short reflex. In other words, food enters the gut senses it, and the gut reacts instantly, all without ever having to check in with the central nervous system. Moving on to long reflexes. Long reflexes are different from short reflexes because they involve the central nervous system, meaning the brain and spinal cord are active participants in this process. This is why long reflexes are often described as the brain gut connection. They're neural pathways that allow the gut to send information up to the brain and then receive motor commands back in response. Unlike short reflexes, long reflexes require CNS input, as I just mentioned. The body uses them when digestion needs to be coordinated with things happening outside the GI tract, like stress, emotion, hunger cues, or even smelling food before eating it. These reflexes use autonomic nervous system pathways, especially the parasympathetic system via the vagus nerve, to communicate back and forth. The sequence will usually go something like this. A stimulus in or around the digestive tract activates sensory neurons. These signals then travel up to the brain or spinal cord where the information is processed. Then the CNS sends commands back down through the autonomic nerves to adjust digestive activity, things like motility, enzyme release, blood flow. So instead of staying local like the short reflexes do, the long reflexes will leave the gut, get interpreted by the CNS, and return back to the digestive system with the appropriate response. This setup allows digestion to be integrated within the rest of the body's needs and environmental cues, making sure we only digest when it's safe and appropriate to do so. A great real life example of this long reflex is something that probably happens to you daily without you even thinking about it. So think about walking into your grandma's house and smelling her homemade apple pie. Suddenly your mouth starts watering. Or maybe you're exhausted after work and you see a plate of buffalo wings and you immediately feel your stomach growl. That reaction isn't for nothing. That's actually your brain gut connection at work. So when we see, smell, or even think about a food that we love, sensory information goes straight to the brain and the brain sends signals right back down to the digestive tract. This is how your body is going to start preparing for digestion before food ever even touches your tongue. So, what actually happens? The brain triggers a whole cascade of responses to get the system ready. This would include the stomach acid production increasing, so the stomach is primed to break food down. The pancreas starts preparing digestive enzymes to handle incoming nutrients. Salivary glands activate, making your mouth water. We casually call this process mouth watering, but it's actually a long reflex preparing your digestive system for incoming food, and it's quite sophisticated. So, even before your first bite enters your body, the GI system is already at work, making sure digestion will be efficient once the food arrives. This is why long reflexes are so important, because they allow the body to anticipate and prepare, not just react. To bring it all together, it's important to understand that short reflexes and long reflexes are not competing systems. They actually work side by side to keep digestion functioning smoothly. You can think of them as partners. Short reflexes manage the moment to moment local control, handling the immediate needs of the gut right when they occur, where they occur. Long reflexes, on the other hand, allow the brain to oversee and fine tune digestion based on the bigger picture, things like hunger cues, stress, emotions, external sensory input, and even anticipation of food, like we just discussed. So rather than one being better than the other, they complement each other to create a very coordinated and very intelligent digestive process. The ENS and the CNS are always communicating. They're constantly sharing information back and forth, which is exactly why the gut is often called our second brain. That communication happens largely through the vagus nerve, and here's a surprising fact to prove it. So, about 90% of the signals traveling in the vagus nerve go from the gut to the brain, not the other way around. Many people assume that the brain is always in charge, but the gut actually sends far more information upward than it receives. That explains why emotions, stress, and anxiety can show up physically in our digestive system. If you're under pressure or overwhelmed, you might notice symptoms like slower gut motility, nausea, cramping, feeling like your stomach's in knots, changes in appetite, or more. It's not just in your head. Your gut is actually talking to your brain, literally, and responding to emotional states in real time. That's why things like stress management, sleep hydration, and mental health support can have such a huge impact on digestion. So, the real takeaway is this: take care of your brain, and your gut will thank you, and vice versa. And of course, here's a works cited as well. Thanks for listening. I hope you learned something today.